Are you experiencing excessive distortions after welding? Are residual stress concentrations negatively impacting in-service life? And are these issues causing your assemblies to be out of tolerance, leading to a high number of physical prototypes, trial and error corrections, high material and labor cost, and even the risk of failure in service? Then it's probably time to switch to Keysight CAE Welding. Keysight CAE Welding combines over 25 years of a proven welding solver with a high-performance computation engine and an intuitive, easy-to-understand graphical environment. It enables fast distortion analysis and in-depth weld process validation, supported by an extensive welding material database, coverage of a wide range of welding processes, including arc, laser, and electron beam welding, for both single and multi-pass welds, and an excellent, scalable solver that runs efficiently on both standard computers and large cluster configurations to minimize turnaround times. Distortion engineering typically begins by identifying the components to be welded. Next, materials and their corresponding properties are assigned. And when stamping simulation results are available, you can also include local thicknesses, strains, and stresses for the highest possible accuracy of welding input data. In the next step, components are positioned in sequence within the positioning fixture. If clamping tools exist in CAD, they can be imported and assigned. Otherwise, they can be created quickly using dedicated modeling functions. The same applies to locator pins, guides, and support blocks. Then, each weld is defined by specifying the heat source direction and B geometry, whether it's a butt joint, laser lap, overlap, or T-joint. The heat source is further characterized by welding parameters such as width, length, penetration depth, travel velocity, energy, and efficiency. The final setup step is defining the clamp closing sequence, clamp forces, clamp strokes, and finally the weld sequence itself. The simulation supports welding with a single robot or multiple robots working in parallel. Once the simulation is complete, all key results can be analyzed, both during welding and after unclamping. This includes temperature evolution, microstructure when required, residual stresses to identify any critical high-stress regions and potential crack risks, and, of course, the core objective of distortion engineering, evaluating the post-unclamping distortions of the assembly and comparing the as-welded shape to the as-designed geometry to verify if required tolerances are met. Keysight CAE Welding is a complete solution for distortion engineering and weld process validation. It allows you to analyze the impact of design decisions, simulate a wide range of welding processes, accurately specify clamping conditions, loads, and pre-deformations, optimize weld sequences to minimize distortion, and investigate distortion, temperatures, residual stresses, and microstructure in detail. By applying Keysight CAE Welding in your engineering process, you can reduce physical tryout time and cost, manufacture assemblies within tolerance, improve lead time at lower cost, reduce the number of physical prototypes, and implement evidence-based countermeasures. Keysight CAE Welding, predictive, efficient, and essential for distortion-free welded assemblies.